Kia ora, tēnā tātou katoa. My name's Shane Clark. I'm the General Manager here at Nurajack, and welcome to webinar number 42. Now, this webinar is set for around 30 minutes. Towards the end, we'll have time for a bit of a Q&A session, so feel free to use that Q&A button at the bottom of the screen there and put your questions in. Don't be too sad if we don't get to your questions. Sometimes we get quite a few, but what we'll do is we'll populate a transcript that comes out with this recording to everyone who's registered today. This webinar is set for 5 NZIA CPD points, just like all the previous 41 webinars, which are available on our education page on the Nurajack website. Anyway, today's topic is about the Nurajack Safety Grid system. We're going to talk about the history of raised pedestal systems. We're going to talk about some of the issues that the industry faces with this type of introduction of this system. And then last but not least, we're going to introduce the new Nurajack Safety Grid system and talk about the features and benefits of that. Why I think today's topic is important to you as a designer, specifier, architect is that I think primarily it's around safety. I think the consequences of failure of getting something not quite right with a raised pedestal system would be more than minor. Another reason to tune in today is to talk about things like how we can protect the waterproofing membranes. So this is hopefully why it's sort of an important topic for you today. A bit about us, if you don't know already. Nurajack has been promoting this raised pedestal system for nearly 20 years now. So it's not our first rodeo. We've got a few balconies and trafficable surfaces under our belt. So luckily for you, I've got some other people on the panel with me today. I've got Lewis Olding, who's the Nurajack General Manager, and we'll have the opportunity to introduce our very own Sam Cam, who's relatively new to Nurajack's. So if there's one key message that you take away today, if you forget everything else, it's probably just this. Nurajack has a solution for complex pedestrian surfaces. It's probably the key message you take away from that today. So before we start, we'll try and make this as interactive as possible so you don't all fall asleep. We're going to run a poll. We're going to pop that up now. Feel free to participate, and we'll show you the results. So quite keen to know who's in the room and what do you prefer? How do you prefer to make your membrane decks trafficable? All right, what's the score there? Excellent. We've got a few pedestal system fans here, Lewis. It's good news.
Hey.
And awesome. All right, Lewis, it's been probably over about 12 months since you and I did a webinar together. It's been a while between drinks. I guess a good opportunity to tell us what's new.
Yeah, well, I mean, it's been a busy 12 months or so. We've actually launched into Australia, which has taken up a lot of our energy and time. And also with the development of the Nuraspike for timber decks, that we worked very hard on during COVID and launched that then. Well, that's now been picked up by one of our suppliers in Italy. So we're now exporting that over to Europe for worldwide distribution. So that's been a really intense bit of work in the last 12, 18 months. And what it's enabled us to do is also bring on Sam Mears as our commercial account manager. And Sam, I'll let you introduce yourself if you like.
Yeah, I'm a tiler. I've been tiling for my adult life, so 20 plus years. Won't get the details exactly on that, but 12 of those I've been doing pedestal tiling using the Nurajack system, which has been good, a good aspect of my business. And then just last year, Nurajack approached and asked whether I'd be interested to come on board. So I, since May, have been the commercial accounts manager here at Nurajack, and part of that has been product development. So it's been interesting being able to inject some of the things I would like to see in the industry. But this plastic grid system we're talking about today has been a big part of what we've been working on, and it's been very interesting.
Yeah, no, it's been great having someone with that practical experience testing our theories, really. So it's nice to know it actually works in the real world. So, all right, we're going to touch on our first topic. I guess our first point is, before we go forwards and tell you what's happening in the future, we're going to go backwards and tell you what happened in the history. So we just go to our first slide, and we can sort of, I think it's throw to you, Lewis, tell us about the history.
Sure.
How did we get to here? I mean, why are we doing this?
Yeah, if we go to the next slide there, Jen, we really have to go back to the 90s, and as many in the audience will know, the leaky home syndrome, they estimate that 30% of all leaky buildings started with a leak in the membrane deck. And the reason for that is that a lot of shortcuts were taken, where people were gluing directly to exterior membranes. Glues were incompatible with membranes, or they'd cause re-emulsification because of trapped moisture, or differential movement between the timber substrate and the tile that's glued to the top would literally tear at the membrane. So in 2005, E2AS1 was released with the update that it required a pedestal in between the membrane and the paver or the timber deck to create a raised removable surface. And about that same time, we were already promoting Nurajacks, as Nuralight was already promoting Nurajacks at that time. Go forward just a little bit further, in 2011, Auckland City Councils and a number of other councils around New Zealand made it not negotiable. They said that they would accept alternative solutions to pedestal systems. And we really saw this influx, or this real growth in the pedestal market here in New Zealand. That's resulted in a fair lot of pedestals, as you all will know, around the place. Majority of apartment buildings that have been built in the cities have pedestal systems on their membrane decks. They're all raised and removable, so that membrane can be inspected at any time. And so it's a really good system for that. It's also the most cost-effective way. A 20mm tile on pedestals is the most cost-effective system for a typical residential balcony. So it's a great way of doing it. In fact, I think we've installed over 1 million square meters of pedestals for tiles. Yeah. Further to that, Shane, once people started using the pedestals to create timber decks or tile decks, they started seeing the benefits of being able to then use them to create level entries over existing concrete or over existing or over other surfaces. And that's where the development of the Nuraspike happened. And we sell probably half of our product goes into those sorts of projects around the country for timber decks. And we supply now through placemakers, Bunnings, Carters, Tile Space, Mitre 10, other tile stores around the country as well, for the domestic market.
No, excellent. Thanks. That sort of a touch on the history and why we do what we do, and why these things are even invented in the first place. Sam, you've been a commercial/residential tiler for 20 years. They look too bad for 21. Look, the first question I've got, so what formal qualifications are required to be a commercial tiler there, Sam?
Yeah, well, it's interesting. There is a qualification for tiling, but when it comes to pedestal tiling, there is no qualification, I suppose you could say. And even in the industry, they're usually not enforced. Most tilers that you see installing pedestals, there's not necessarily informal training that's provided. So you do see quite a range of quality when it comes to insulation. Another sort of issue, I guess, that we see in the market, and I think it's quite interesting, is that we do see a range of quality when it comes to the type of pavers that are used. So there's no actual standard that is required or rating that is required when it comes to the strength of the pavers. It's fairly widely accepted that a 20mm porcelain can be considered a structural tile. We also see natural stone, obviously, being installed, as you can see in the image there. That might be 40mm thick, and then there's concrete solutions, might be 50mm thick. But within the industry, it's actually over to the supplier of the paver to say that it is a structural tile and not necessarily provide a rating. So we see a range of problems that result.
So there's a few missing parts when it comes to the regulations. So I see they've got very tight regulations around things like slip coefficients and whatnot, but not so much around the strength, I guess, of the tile.
That's correct, yeah.
And so in a
Yeah, yeah.
residential situation, it's probably less of an issue. But in a commercial situation, it can cause some challenges. If we go to the next slide.
I think, yeah, I was going to say, I think that the next slide sort of illustrates the consequences of failure of a tile.
That's an interesting photo, Shane. What happened there, do you know?
Allegedly, it broke. I think someone was on it with a skateboard. Is that
right?
We asked Shane to test this the tile to destruction, and he certainly did that. It takes a lot of effort to break a 600 by 600 by 20 mil tile, but Shane was wearing some hard-soled shoes, really went for it with his heel, and it broke. And that's to be expected. Things have a break point, right? So, but I think, Shane, you were even surprised that it happened.
Yes, I was, yes, yeah.
But this is one of the challenges that we sometimes face in a commercial environment, where things aren't specified maybe to the level that they need for the amount of traffic that is going over that deck area. Some consideration needs to be given as to what sort of traffic is being put over it. We've had situations where people later will drive a scissor lift over a floated tile deck, and it's like, well, have you considered the point loading? The actual Nurajack itself can withstand 1,000 kgs each Nurajack, but the tile, a typical 20 mil tile, is maybe 400 to 500 kgs per square centimetre, which is a lot for a residential deck. But in a commercial situation, it might be something that we need that should be considered as to what the paver strength is. We've got on the next slide there, Jennifer, you can just shoot to that one. We've got a couple of examples around the country over the years that I've just sort of tucked away in my mind. We had a school in central Auckland where skateboarders would come in and they would do the tricks and that sort of thing and break tiles. And so on a Monday morning, when the teachers and children arrived, they'd have holes in their deck, in their podium deck, that they'd have to address. We had a church here in Auckland who has quite a large podium area, and whenever they do a community event, well, not every time, but now and again, people move big heavy items across, and the tiles were oversold by the original supplier. They were actually only 12 millimeters thick, and they were breaking all the time, causing a 300 millimeter gap to appear in the floor. There's a public space in the South Island when it launched, and this is a picture on the right-hand side here. It was a stone that was supplied, and it had invisible fissures through it. And so when they launched, all of a sudden, a number of the stone pavers started breaking, with thousands of people walking over it. So, and then we had another school up here in Auckland where people would break in over the weekend, and they found that they could vandalize by lifting the pavers, breaking them, lifting them off, and then throwing them off the balconies because the pavers weren't secured. So there are some challenges there that the industry does face around paver selection, but also how to have the right product in the right place.
Excellent. There's some good illustrations here of what can go wrong if it's not done right. And I guess particular with the stone pavers there, if they're a natural product, no one stone paver is going to be equal to the next, probably even within the same batch. Would that be fair?
Yeah, and oftentimes, because stone is cut out of a rock, as you cut through, you start getting a repetition of the fissures, and so I get a truckload of stone on site, but then every 16th stone has a fissure through it that is weak. So it's those are certain challenges. There's one other area, Shane, before we move on, actually, that is quite it can be a challenge, and that's wind uplift.
Yeah.
And we'll talk about that. We're purposely going to talk about that later in the webinar, aren't we? But that is something that needs to be considered too, and it can cause a challenge because there's been a lot of talk in the industry about wind uplift here in New Zealand, but we'll cover that off a little bit later.
So we're going to, next slide, we're going to talk to the safety grid system. But before that, we've got another poll to run. Just want to pop that one up. So I just want to know what people's experiences around getting pushback with wind uplift resistance with floated decking surfaces. So just quite keen to see how popular this topic is, or not. Cool. So I'm going to share the scoreboard there. Okay.
Good to know.
It's cool. So obviously we've experienced it a little bit because I guess that's where the questions come to. So if we just flick to the presenter mode, I think Sam's just going to show us a piece of the Nurajack Safety Grid system to give it some scale, and just describe what we're looking at here, Sam.
Yeah, so this is our grid. I mean, it's not as easy to see perhaps, but it's quite rigid. It has a dovetail system, so they lock together very quickly and easily. It's a 500 by 500 panel, and it's 40 mil thick. And the grid itself has multiple locations that lock into the head. You can see the corner there, and there's one right in the center. So in general, the jacks are supporting just the corners of the grid, but in certain circumstances where a higher rating is required, there are other locations where we can add pedestals and still adjust them.
And what's the safety grid made from, Sam?
Yeah, it's a polypropylene, and like all our products, it's a high component of recycled material. So with this, it's 80% recycled polypropylene.
Nice.
And how hard, like you've installed tiles on Nurajacks, is it a similar process to install the safety grid?
Yeah, that is a good question, and was actually quite nice to discover. It's a very simple installation process. In fact, anyone with experience in installing tiles directly to pedestals would very quickly pick up the process. In fact, we would describe it as faster and easier to install the square plastic grid than it is to install tiles. So it's pretty straightforward, the process.
All the other features of the Nurajack are still available, such as the ability to adjust the jack from above the grid and the self-leveling head and those other things. So again, those sorts of things like the self-leveling head protect the membrane, because you've got no chance of the jack riding up and point loading the membrane and things like that. Yeah.
Nice. All right, so we've talked about the history of the raised pedestal systems, how we got there. We've touched on a few of the issues that the industry faces, and we've sort of shown you what the safety grid looks like. Now we're going to actually introduce the safety grid system, I guess, and we can sort of explain how all the components go together. So what are we looking at in this picture here?
Yeah, I can answer that initially. Obviously, that's our grid there, and the pedestal underneath that it sits on and interlocks onto. And then you've got a range of surfaces you can put on top. So anything from a structural paver. Grass is a really awesome option that it can be used for. We are seeing natural stone that's not structural being stored over the top of it. And it seems that the combined strength of the stone glued to the grid is adequate. And something also that has been cool, you see the bottom there, a smaller format tile. And so it might be that a structural tile that's smaller in size needs to be used to match something that's existing, but the amount of pedestals that are required, or it may not even possible because the tile's too small, the grid works as a cheaper option to provide a platform to put that smaller format tile over. So there's a few of the areas that can be used.
So we've got a project actually that,
yeah, I was going to say,
some brick tile paving that needs to be floated, and if you were to put jacks everywhere, it just blow the cost of the project out. But by putting the safety grid down, they can lay that brick tile in like a herringbone pattern, and glue it in place even, so that it's actually got some solid footfall, and it's a great solution.
Cool. So I think we've got an action shot in the next slide, Sam, of I guess an in-progress installation.
Yeah, so this was a residential home in a nice area, East Auckland. The owner didn't like the idea of tiles over pedestals, as many don't. It doesn't sound right. They might have concerns, the fact that the tiles are simply floating. So he asked for a fixed solution, and we could offer that. This is a structural tile you see him put down here. However, he opted for it to be glued on top of our grid. But what was quite neat is we went through the process of training the tilers to use it. They installed a whole grid everywhere. They started laying the tiles, and when the owner walked on that end result before it was glued down, he was happy with that finish. So the end result of structural tiles over the grid system in this scenario is a very firm, good end result. And for peace of mind, he knows it's got full support underneath, as well as there's always the option of gluing it down if that was still required. Yeah, that's
So it
that
actually
image.
changes the tactile feel of the tile underneath. Is that correct?
Yeah, it did. And if you notice, this
Yep.
is a very large format tile. So it provided a good solution. You can put support everywhere under any format. And there is actually one extra feature of this job. If you look on the left there in the photo, is a level entry, but the ranch slider had no aluminium at the base of it to contain the tiles. So of the whole project, there was no glue down needed, except that one location. We were able to provide containment there, which wouldn't have been achieved with a normal floating system, and a good sort of perk, you could say, of using the safety grid.
Yeah, right. Nice. All right, let's flick on to our next slide.
So this is a project on the north shore of Auckland. You'd see they had existing tiles down, glued to a concrete substrate, running to drainage, and their daughter ran out of the house, slipped over on the tiles, cracked her head, and ended up in Starship Hospital. And so the father just said, "Look, we need to do something about this." And they were considering ripping the whole area out. And he stumbled across our product. We'd only just really launched the safety grid at that time. And so he installed it all himself. It's a DIY project, actually. Installed the safety grid himself, then overlaid it with a Tiger Turf, I think it was, or it might be a Team Turf, one of those brands. And because there's a couple of features that benefit here, that because it's raised, that means that sometimes turf gets extremely hot underfoot, but because it's raised and it's on a plastic grid rather than an aluminium or other type surface, it doesn't heat up, so it stays cooler, and that means it's more comfortable to walk on. His daughter goes out there now and has a netball hoop and plays netball on it and that sort of thing, so it's a very functional surface for them. They could have run tiles in there as well, and mixed and matched that surface, and he's actually thinking maybe going back and maybe do that at some point. And when I spoke to him about it, but a really good use of that system, and it saved so much money because he didn't have to remove everything to be able to sow lawn. And it's actually, he's got a level entry lawn surface, which is pretty cool.
Yeah, great. I want to flick on to the next case study.
Sam, do you want to talk about this one?
Yeah, this was really neat. This is a nice resort that wanted to have their same indoor-outdoor feel, and so they wanted this limestone, but it's non-structural, and so we were able to offer the safety grid and glue the limestone to it. And a few advantages of using the grid here. I mean, if you think about this is largely a French lay area, which would require a lot of pedestals. They were able to save cost by using the grid, and also the strength of the grid enabled them to use that product. No, a really good result. We did some testing for them just to ensure that it would be a good result, and Lewis was able to jump up and down on the tiles that we laid on the grid and do a good solid test, I would say, from observation. And after 30 seconds, there was no breakages. So we did keep going and pushed it until they broke. And what was interesting is, even though there was now a crack in the tile, you could hardly see it and it wasn't dangerous. So that's something that you can achieve with the plastic grid system, is that extra safety aspect. So in some situations, you could not afford to have a broken tile. If you think a rooftop bar, maybe a fire exit, then a solution like this really it reduces that risk.
Yeah, so we really see a
Yeah,
couple of things here. You can choose a unique surface now. You can French lay pattern, which is really unique, and we've never really done that on pedestals before. And then if it's a commercial space for dining or even a party, a wedding event, there's no chance if the tile was to break. If someone dropped a bottle of wine and smashed the paver, it's safe. You don't have to worry about blocking off the area. That the staff don't have to deal with it. It's safe, and so it's really it ticks all those boxes for this customer.
Yeah, no, I love that that concept of testing to failure. So
Do it well, Shane.
very very obvious then, isn't it? So
Go to the next slide.
okay,
We'll see another project. And this one's talking more about containment. So with floated tile systems, you need to be able to contain the movement. And this is something really important to understand as a specifier, that if you do not, because the tiles are generally not glued down to anything, they will walk apart unless they are contained. We use tile cladding spaces, or we have a new product called a tile cladding clip that's adjustable. The building code E2S1 requires a 12mm gap around the perimeter. But there's certain situations like this one illustrated here. Maybe Sam, you can talk us through it, where they weren't allowed to brace off the toughened glass. Is that right?
Yeah, that's right. And it was something that needed to be addressed perhaps after the fact. So by adding simply 2 rows of grid here and gluing down the perimeter tiles, we were able to provide the containment needed. And in a couple of situations, there was also a cantilever issue on this job, where the pedestals weren't able to support the tiles right to the edge. By gluing down the tiles onto the grid, it then provided enough cantilever that this was no longer an issue. So a good example really of some problems that it can solve, even in retrospect.
And so when you think about an emergency egress area, you might have a large membrane area heading into a building, but you don't want to necessarily add the cost of having the safety grid across the whole area, but you need to have the safety grid in the emergency egress area. Well, we can bridge on and off the safety grid very easily. It just by using the jacks to support the safety grid and then using the jacks to support the edge of the tile, it's totally fine. And so in this instance, we did glue the tile down to the safety grid, but you don't need to have that support. Excuse me. You can just loose lay over that safety grid as well, and which will save a little bit of cost because you don't have to pay for the glue and the time, the labor for the glue. But yeah, so all those options are open.
excellent. All right. So we're going to lastly quickly touch on the last feature of the safety grid system, and that is the windproof thing. Now I'm going to I've had a question that's come up, and I guess it's kind of in line with what we've seen in the poll about wind uplift. Is wind uplift really a thing, or is it a bit of an invention?
In my opinion, and I've been heavily involved in floated tile systems for around about 16 years now. I only know of 4 projects that have ever had a wind uplift issue. So it's actually not a major issue for New Zealand. There's definitely issues in Hurricane Alley and certain places around the globe that experience hurricane force winds. But for a typical residential or apartment style deck, the way we design them behind balustrade and that sort of thing, they normally don't experience that issue. And as I said before, we've got over 1 million square meters of 20mm tiles on Nurajacks, and we've only had 3 issues ourselves, and one other competitor has had an issue too. The issues in every case haven't related to just a high wind zone. It's actually related to the design of the building. So, for example, one project in Wellington that had this issue, I think it was a 9-story building. It had a balcony on the 9th story and balconies on the ground floor. So where do you think the wind uplift issue would be? You'd think it'd be at the top, where it's going to get the most fast wind speed, but it wasn't. It was actually on the ground floor. And so theoretically, the wind was coming down the building and water falling at the building and causing the tiles to uplift. And that was overcome simply with our Nurajack windproof system. But when we were developing the safety grid, and we started playing around and focusing in on the glues and working with our suppliers around that sort of thing, and we started doing our testing, we saw some incredible results. Sam, do you recall what we sort of achieved there when we went to Opus to get these tested?
Yeah, I mean, our initial intention was just to confirm that arc glue could stick to polyurethane, and it notoriously can't because of the nature of the grid. We're able to get grip into the holes, and when we did a direct pull test, the KPA rating was well above 11 for some of those products. So we're quite confident to provide a KPA rating of 11 for wind uplift if you're gluing down to the grid, which is interesting. It's high, obviously, and essentially what that means is because you've just joined the entire surface of tiles to the grid, it makes the real wind uplift rating the combined weight of that deck, which is obviously going to be high, and then even more so if engineers or architects see the need, you can put down edge brackets that would contain the deck itself. So quite a cool end result that we weren't expecting from gluing tiles to the grid.
So yeah, I guess whether it's an urban myth or not, we can solve it with the safety grid.
And we can solve it with a product that's light too, which is often a consideration in areas that people are worried about wind uplift. There might be weight constraints. So it's a good, strong, light solution, basically.
Yeah. Excellent. All right. I am conscious of people's time, and there are a couple of questions that have come in. So we're going to jump to the presenter mode, and we'll just answer a few of the questions that have come in. There's been a few, and we do appreciate that. We will have to send out some of the answers in the transcript. But the one common theme that's coming through, Lewis, in your first stanza, you talked about the history, and we've talked about how we can't glue tiles anymore. Then you've come back with a system where we're gluing tiles. Can you just clarify the raised removable part of that system?
Yeah. So after 13 years of telling people that you can't glue down, I'm now telling people to glue down. That's not necessarily the case. No. When we do glue tiles to the safety grid, they are removable, and we can do it with a cheese wire or a razor wire. Plumbers use those quite regularly, where we cut the glue under the tile and then remove the tile. However, if you've got a large podium area or something like that, you can because it's a dovetail jointed system, you can easily identify areas, even cut the tiles in those areas with a lifting eye or something, so you can actually access important things like your outlets or that for inspection. So it's just about thinking ahead where you want to have that access regularly, and then if a tile was to break or something like that, we can actually detail and remove that tile and then re-glue to the existing grid very easily. So it's still removable.
Are we able to say what type of glue? There's lots of questions around the type of glue. Is this something we have, or do we know the type of glue we use?
Yep, we worked really closely with one of our suppliers. They did extensive testing, and we've done extensive testing. It is a polyurethane type glue, but it's modified, but it is readily available too. So we tested about 3 or 4 different types of glues. It comes in a 600 ml cartridge, which is gun applied, and relatively simple to apply. Depending on the applications, how much glue you use. So if it doesn't really require adhesion for wind uplift or anything like that, you can use a little bit less glue. If it's if you're worried about the structural integrity of the tile or paver, you might want to use more glue. So it all depends, and we can certainly give suggestions around that.
Great. This sounds like a commercial tiler question here, Sam. The safety grid comes in 500 by 500 squares. But tiles come in 600 by 600. How do you work that out? How does that work?
Yeah, so essentially the way that you want to think about it is you're just creating a raised flat platform, and commonly it is a 6x6 that goes on top, but you can get support anywhere on that platform. So really it's just a new substrate that you can work with, and you can lay any size format tile on top of that. So it's not really an issue, so to speak. Yeah, and to be honest, it's more the pedestals that are providing the support. So if there was an issue, for example, more weight was going to be placed on those tiles, then you can just simply add more pedestals coming up to centers of 250, even smaller if needed.
Sure. Another question here. How low can we go? It's the with the safety grid, how low can we go? And I guess, again, to ask that question again, how low without the safety grid?
So our smallest pedestal that's adjustable, screw adjustable, is our Star T, and that can go down to 8 millimeters. So you've got your 40 mil grid and your 8 millimeter pedestal as the starting point. Then whatever paver and you have on top of that. So if you allowed, if it was a 20 mil tile, that's you're going to be at around about what is it, 70 mils? I think, is that right? I'm not sure if my calculation, but with my cold, I'm not sure if I'm 100% right there. But yeah, that sounds about right. So yeah, that's as low as you can go. Now, keep in mind, you can always bridge off that if you need to go lower as in a renovation type scenario, but the tile would have to be structural and to go down lower than that. That makes sense.
Excellent. Good answers that. Look, we are pushing for time, and there's still plenty of questions to answer, which I have repeatedly said we'll come back from the transcript and answer all of them. So don't feel like you've been left out. So that was the Nurajack safety system. Hopefully, we've sort of outlined the history, where it come from, why we even do this. We've sort of highlighted a few of the issues that we see around the bar to enter the market to become a commercial tile. No offense there, Sam. But also the type of tiles and stones that get used, and we've sort of hopefully introduced the solution to most of those issues. Now I'm just going to run a quick final poll. If you're working on a project at the moment and you'd like a follow-up, you just want to, if you feel free to pop your details in there, or tick the box, we'll know who you are, and one of the team will reach out to you. And just while that's sitting there populating, I just want to let you know, a bit of an announcement, that hopefully you've subscribed to the Nuralight emails. We've got our own exciting event coming up over the next few days. It'll be sort of launched in the next few days. We're holding the Building Science Summit in New Zealand, which is worth 60 NZIA CPD points. Nuralight, together with some of our friends in the industry, are bringing out some of the industry experts from New Zealand, from the States, and from Canada. They're going to share some sort of practical insights and their experience in advanced building envelope solutions. So keep an eye out for that. There's 3 locations. These are live events in Christchurch, Wellington, and Auckland. So yeah, keep an eye out for that. I look forward to seeing you there. That's been us. That's been our webinar. That's a Nurajack Safety Grid system. Thanks very much for joining me on the panel, gentlemen.
Thank you.
No worries. Been a privilege.
Excellent. All right. And thanks very much to the audience for watching. And we'll see you on the next one.
Thank you, everybody.
Ka kite.